Hey guys, this is Arvind. You are watching Learn with Arvind. In this video, we will be discussing on Fourier series in which a function is defined in two or more subranges. If you are having a function and if it is defined in two ranges instead of a single interval, this is what we mean by a function defined in two or more subranges. For example, take this function. F of x is equal to minus pi in the interval minus pi to 0 and x in the interval 0 to pi. This function is defined in two intervals. This function is not having a single value for a single interval. Instead, this has two values in two intervals. This is what we mean by function defined in two or more subranges. If we plot this function in the range minus pi to 0, pi. If we plot this function, it is minus pi, which is a constant. So it would be a straight line, constant straight line in the range minus pi to 0. In the same way, if we plot x, if we put value for x is equal to 1, then we will be getting f of x is equal to 1. The same way, if we put x is equal to 2, then we will be getting f of x is equal to 2. Therefore, this would be a straight line which would look like this. This function is defined in two or more subranges. And you could see another thing. This is also example for discontinuous function. We can clearly see a discontinuity in this function. If a function doesn't continue and you could see a discontinuity, this is what we mean by a discontinuous function. Let's see an example for function defined in two or more subintervals. For instance, take this function. This is a square wave. It is 0 in the range minus pi to 0 and h in the range 0 to pi. Now let's plot this function. You can see that it is 0 in minus pi to 0 and h at 0 to pi. For the other intervals, it will look like this. This is nothing but a square wave. Now the Fourier series f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx. Now we will be finding the constants a naught, an and bn. A naught is equal to 1 by pi integral the limit minus pi to 0 f of x dx plus 1 by pi interval 0 to pi f of x dx. Now substituting the value of dx, we will be getting, since f of x is 0 in the range minus pi to 0, this entire term would become 0 plus 1 by pi integral 0 to pi h, which is a constant, so we will be taking it out of the integral dx. Integrating dx would give us x. So, assuming here it is 1. Now substituting the limit, we will be getting h by pi into pi minus 0, h by pi into pi and pi would get cancelled, so a naught is equal to h. Now we will be finding an. An is equal to 1 by pi integral minus pi to 0 f of x cos nx dx plus 1 by pi integral 0 to pi f of x cos nx dx. Now substituting the value of f of x, this would become 0, and substituting the value of f of x here, it would become h by pi integral 0 to pi cos nx dx. Now integrating cos, we know that integral of cos nx is equal to sine nx divided by differentiating nx, we will be getting n put that in denominator. Now substituting this value, that's integral of cos nx would give us sin nx divided by n in the range 0 to pi. Substituting the limits, we will be getting, before that we knew that sin n pi and sin 0 is equal to 0, therefore an is equal to 0. Now we will be finding bn. Bn is equal to 1 by pi integral minus pi to 0 f of x sin nx dx plus 1 by pi integral 0 to pi f of x sin nx dx. Since the value of fx is 0, this entire term would become 0 plus f of x is h, which is a constant, so it is h by pi integral 0 to pi sin nx dx. Now integrating sine, we know that integral of sin nx dx is equal to minus cos nx divided by n. The integral is given by minus cos nx divided by n in the range 0 to pi. Now substituting the value of, before that we are taking minus as common outside of this, and would turn cos n pi minus cos 0 minus h by n pi. Since cos n pi is equal to minus 1 power n, minus cos 0 is equal to 1. Cos n pi is equal to minus 1 power n. It is minus 1 if n is odd and plus 1 if n is even. If n is odd, then this function would be minus h by n pi minus 1, which is nothing but 2h by n pi. If it is even, then bn is equal to 0. Bn is 0 for n is even and 2h by n pi for n is odd. Now substituting this value in Fourier series, the required Fourier series is f of x is equal to a0 by 2. A0 is given by h. So h by 2 plus summation n is equal to 1 to infinity. Bn is 2h by n pi times sin nx. This is the required Fourier series which is defined in 2 or more subranges.